Hello class, welcome to section 4.1 where we're going to start learning about fractions. So some of the questions that you're going to get is just going to be a little graph here, and it's going to say how much of the whole is shaded. A fraction, the numerator is the top number, denominator is the bottom number. The numerator tells you how many are there of what you're looking for. The denominator means how many there are total, so the whole. So here we have 1, 2, 3, 4, 5 sections. So our denominator is 5, and we have 1, 2, 3 sections that are shaded. So the part that's shaded is 3/5. So 3 out of 5 are shaded, and that's one way we can say fractions as a ratio, 3 out of 5. It's also 3 divided by 5, or just 3/5. So the next type of question that you may have is something like they want you to change 1 over 3 into another fraction, an equivalent fraction, with a denominator of 24. And so we know our denominator is going to be 24, so what is our answer going to be here? And what we can look at is the way we'll do this is 3 divided into 24. And when we do that, we will get 8. So 8 times this numerator, which will be 8. So 8 over 24 is the same as 1 over 3. Basically what we're doing here is kind of the opposite of reducing a fraction. Because if you remember, and we'll talk about this later again, but when we're reducing a fraction, we're dividing both the numerator and the denominator by the same number until we can't go any farther and there's nothing that can be divided into both of them. And here they both divide into 8, but with this example we're multiplying both by 8. So the next one, another one like that, is say we have 7 over 10 equals something over 30. So now we need to know what number goes here. And we're going to do it the same way. Let me change the color here. So we're going to do the same thing. 10 or 30 divided by 10 is 3. And 3 times 7 is 21. So our answer here is going to be 21. So with the equivalent fractions, those are just fractions that equal each other. And that's what we're doing here. So some other examples, say we have 4 over 9, that equals 8 over 18. It equals 12 over 27, and it equals 40 over 90. So these are all equivalent fractions. They are the exact same ratio of each other, and they mean pretty much the same thing. So in these few examples, we went from a smaller fraction to a larger one. So now let's reduce. So say we start with 35 over 49, and we want to reduce this as much as we can. So we need to find a number that will divide into both of these, and one number is 7, so we'll divide both the numerator and the denominator by 7, and we will get 5 over 7. And that's as far as we can go there. Okay, how about though if we have 81 over 63, and we don't know what the greatest common number is. So we can do just any kind of number. So let's divide both by 3 and see what we get. We'll get 27 over 21. And 3 will go into both of these. So we'll divide both by 3 and we'll get 9 over 7. However, okay, so we did that in multiple steps, but if we start again with 81 over 63, and we know that the largest number that will go into both of those is 9. We're going to get 9 over 7 and do it in one step. The point here is that even if you don't find the greatest common factor, you can still use a common factor and just keep going until you can't anymore. Okay, so a few other things as far as fractions go. When we have x over x, that equals 1. So 3 over 3 equals 1. 44 over 44 equals 1. And let's say 3x over 3x equals 1. Also, when we get into measurements, feet divided by feet also equals 1. And that's important to know. Also, x, which means anything divided by 1, equals just that anything. So 3 divided by 1 equals 3. 2 divided by 1 equals 2. Okay, so knowing those, let's look at something that has both numbers and variables. So say we have 4x to the 5 over 10x to the 3. And we want to simplify this. Let me do something real quick, fix this. Oops. Okay, so 4x to the 5 over 10x to the 3. So we can break this up. Here, this means, remember what the exponent means? It means the base multiplied by itself however many times the exponent is. And the exponent only affects what's right in front of it. So we keep the 4, and this means x times x times x times x 5 times. So we can put x, 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 5 x's. And here we have a 10, and we have 3 x's. So this is one way we can do this. Remember, x divided by x equals 1. So let me change the color of these. This x divided by this x equals 1. This x divided by this x equals 1. This x divided by this x equals 1. So now, what we have, we can simplify the 4 and the 10, divide both of those by 2, and we'll have 2 on top, 5 on bottom, and we still have 2 x's on top, so 2x squared over 5. That's one way that we can do this. When you're using myopenmath, you may need to put parentheses here, unless you're using the math quill. Next, let's say that we have 18x squared over 48x to the 3. I'm going to split this up. Actually, I'm not going to on this one. Yeah, I will. So we're going to have 18xx over 48xxx. So when we have this x and this x will divide to be 1. This x and this x will divide to be 1. Now we have an x in the denominator but none in the numerator. And what number will divide into both 18 and 48? We could use 6. So I'm going to divide this by 6 and this by 6. We're going to get 3 on top, 8 on bottom, with the x also on the bottom. So 3 over 8x. Next, let's do one that has both x's and y's. So 20 x to the 3y over 28 x to the 4 y to the 3. Okay, so I'm going to break this up again. But this time I'm also going to break up the numbers. So 4 will go into this. This is 4 times 5 times x times x times x times y. This one, the 28, is 4 times 7 times x times x times x times x times y, y, y. Okay, so now we can just divide everything by 1. So the 4 divided by 4 is 1. X divided by x is 1. X divided by x is 1. X divided by x is 1. Y divided by y is 1. So what we're left with now, on top is the 5. On the bottom, we have the 7. We have 1x and 2 y's. So x, y squared. So another one that's like this, one more. Let's say that we have, I'm going to use the same numbers, 20 x to the 3, y to the 5, and 28 x to the 4, y to the 3. So this time, everything's the same except for this y to the 5. We already know that this is going to be a 4 and a 7, but I'm going to go ahead and break that into 4 times 5 times x times x times x, y, 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 all over 4 times 7, x, 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 y, y, y. Okay, so I broke it up into the 3x's, 5y's, 4x's, 3y's. And let's divide what we can. 4 divided by 4 is 1. X divided by x is 1. X divided by x is 1. X divided by x is 1. Y divided by y is 1. Y divided by y is 1. Y divided by y is 1. So now we have 5 on top and 2 y's. So 5y squared all over 7 and just 1x. So we have 5y squared over 7x. Again, you may need to put each of these parts into parentheses or inside parentheses so that myopenmath will register it as a proper type of fraction. And that is it for section 4.1.